Hi guys, this is Tebogo Diraditsile, and in this talk, I'll be taking you guys through automation and provisioning with Ansible, and this will be important to you specifically for the national round and ISC when you need to use Ansible for user management as well as cluster configuration. Um, so usually a cluster has many nodes that must be configured identically, and doing this by hand is usually slow and error prone. And you end up seeing this result in benchmarking where you start seeing mysterious bugs. So therefore, we end up needing a tool that is consistent and reproducible, and it is basically able to automate the process of cluster configuration and provisioning. So this tool is what we call Ansible, an open source tool for automating configuration and provisioning. So what this means is this is a tool that can automatically configure your cluster, install packages, and also a tool that can deploy clusters as well. So installation of Ansible happens on the head node only, and it uses SSH to communicate with the other nodes. So with Ansible, you describe your state that you want in a readable YAML file, and then you basically run that, and it ends up doing those changes on the nodes and the head node as well. Scripting versus Ansible. So some of you guys have had experience with scripting, and you might ask yourself, like, why would I want to use Ansible over scripting? So with shell scripting, you basically write how you want to do stuff, step by step. And with Ansible, you describe the state that you want the cluster or the nodes to be in. So why you'd want to use Ansible over scripting? First off, could be you could be dealing with a lot of nodes, and scripting would require you to SSH to the individual nodes. Let's say you have something like 50 nodes. So SSHing into like all of the nodes and writing a script is not practical. And another big thing is with Ansible, it basically only works out what changes are needed to reach a particular state. So if you ran a script in the past and you run it again, it's not going to affect the cluster because if there are no changes, then Ansible won't make those changes. However, with scripting, you can't really guarantee that. So you might end up doing changes you didn't intend on making. So with Ansible, we have what you call an inventory file. So an inventory file, which is this file here at the bottom, it's basically a file that tells Ansible which host to manage. So as you can see from this file here, we have 4 hosts. We have head, compute 1, compute 2, and compute 3. So and these hosts, they're actually grouped. As you can see under head, we only have 1 head node, and under compute, we have like 3 compute nodes. So what's nice with this is you can end up targeting specific configuration to specific groups of machine. Let's say you want to configure a head node in this particular way. So you can run Ansible to configure the head node only in that way, and then you can run Ansible again to configure the compute nodes in a different way. So this is one of the quick commands you can run once you've set up Ansible. With this, let's look at the first command here. So you'd start with Ansible and then next to it all. So this is where you describe your host, and it will check this in the actual inventory file. So all means run this application across, or run this command rather, across all nodes. So -I, this is where you specify your inventory file, and then this is our classic pinging command. So this will basically ping all files, all nodes specified in the inventory file. And then the second command is this one here, where you basically run uptime on only the compute nodes. So Ansible playbooks. So a playbook is a YAML file that describes the desired state. So as you will see, a playbook is basically made up of tasks that you want to run, and each task uses a particular module to achieve this. So some of the modules you'll find is apt or DNF. So these are the modules you would use if you want to install packages on your machines. Another module you'd use is copy. So you could use this if you want to place your config files on nodes, or if you want another important one could be servers. So with servers, you can use this to start and enable particular services, stuff like your SSH, if you want to use servers for Slurm and stuff like that. Another one could be user. So this module is basically what you use if you want to manage user accounts across the cluster. So this is an example of a playbook. So this playbook we have here, as you'll see, it has a name. So the name there, we have configure compute nodes, and then host. So that describes the host that we're targeting. So for this one, we're only targeting our compute nodes. And then become there just tells Ansible that you need to run this as root. And then this is our particular task we're talking about. So with this task, the name is install build tools. And then the particular module we're using is apt. So as you can see, what the module name is build essentials and state present. What this means is, it means that I want you to install build tools on a node if build tools is not tools is not there, or build essentials. So you would run this Ansible playbook using this command here at the bottom. So there could be Ansible playbook -i inventory and then the name of the playbook. Idempotency. So as I had mentioned earlier on, rerunning only changes what is not already correct. So that's one nice thing about Ansible, and it's basically safe to run at any time. The cluster will always converge to your desired state, and this is basically what sets Ansible apart from plain shell scripting. Managing users with Ansible. This is probably one of the most users of Ansible, managing users. So on a cluster, every user must exist on every node, right? So, and you need to do this with the same UID. Otherwise, if you don't use the same user ID, you end up having issues when the user has to log in, and home directories also end up having issues, particularly in environments where you sharing your home directory via NFS, and this can cause a lot of issues with file ownerships as well. So we're going to have two core modules when we're working with users. Particularly, we'll have group. So this module will create the group, and then you have the user module. So this one will create the account. So this will create the name, the UID, the shell, and the home directory. So you'll define your users as a list, and then you loop over it, and then one task will basically create all of the users. And one important thing will be state present. So like I had mentioned earlier on, so this will make sure that it will only create the user when the user is not on the system. So a usable cluster also needs groups. So with groups, you'll find out that when you create your user for the first time, the user might only fall within their group and maybe some other group. However, you might need to give the user group sudo access, so this allowing the users to run as admin. And then another important thing might be file permissions for the home directory and other directories as well, specifically for the SSH directory. So if this is not set up correctly, you might end up having login issues for the user. We'll look at a user creation script later on in the session. So far we have configured nodes that have already exist. But what if you want to automate the process of deploying nodes? So Ansible can also create a node on OpenStack, and then obviously you can configure the node. So this is one of the nice thing about Ansible as well, provisioning. What we have here, this is an example of a playbook I made. So I used this playbook to basically create an instance on OpenStack. As you guys will see from this playbook, most of the attributes, you guys will be aware of the attributes since you've kind of like deployed your own node on OpenStack. So some of the stuff here will be like I've already discussed the other stuff, but if you check here under the OpenStack aspect, you'll see stuff like your flavor, your image, your network, your security group, and all of those. Those are stuff that's already on OpenStack, and I had already configured that. So this playbook, I basically use this playbook to just create another instance. So this is a huge time saver if you want to like create a lot of nodes at one time. So this is what the output will look like when you're creating a node. So this is the command I ran to deploy that, and then this is the output you would get. And then what we have here, this is basically just showing the node that was just created using Ansible. Thank you. Now we're gonna move on to the second aspect, which is basically just showing you how to like create your own user using Ansible. So in this part of the video, we'll be looking at how to deploy users across the cluster. So we have a 3-node Ubuntu cluster here. This is how our host files look like. So you can see we have 3 nodes. We have a head node, and then we have our compute nodes up here. And then our inventory file for Ansible looks like this. Then you can see we've basically defined our host in this inventory file. There's our head node there, and then there's our compute node. So having an inventory file like this, once again, allows us to deploy to specific nodes. So if we wanted to, we could just deploy on a compute node or just on a head node, or we can use a combination of the two. So we should basically be all. So the playbook we're gonna use, it's gonna be this playbook called deploy users to. So this playbook, I'm just gonna go through the important parts and some of the design decisions I basically took. As you can see here, we just created a list of all our users. And once again, the UIDs here are pretty much important because stating them like this statically allows the UIDs to be consistent across all nodes. And then what I also did is like I've kind of partitioned the tasks to basically have tasks that are only going to run on the head node and those that are only going to run basically on all nodes. So all the tasks under this comment here, these are all tasks that are going to run on all nodes. So this includes creating the groups for all users, and then importantly also creating the users here. And then as you can see, with this one, I decided not to create the home directory. And the reason for that is the home directory is shared via NFS. And as you will see later on, what we're doing is we're going to create the home directory under the commands that are only going to run on the head node. So when we run on the head node, that's only the time we're going to create that home directory. And also we have this part where we are giving all the users sudo access. And one thing you can also notice is this one here, where for the software user, we are not giving the software user sudo access. And this is because we decided that the software user will basically just act like it won't really be a user. It's just going to act like a directory of some sort where all users basically deploy their applications under or just store all sorts of files under software. So, and that is easily achieved by basically allowing all users to be part of the software group. So as you can see under this part, we make all users basically fall under the software group, and therefore having them inherit all the files of software. And then for the tasks that are going to run under the head node, these are the tasks that are going to run under the head node. Obviously, the first task is just ensuring that the home directory exists, which is something we didn't do before that. And another important thing, which might be different for you, might be this one where, for us, I decided to basically copy the SSH keys under the existing user on the system. So, and then basically copying them to all other users. So for us, because this is a system that you know, I think only about 4 people are basically going to use. So it doesn't really matter, if you put the keys like that for everyone. But in cases where like the system has to be like secure, and you don't want the sharing of keys, you probably won't have something like this here. So and then as you can see, as well, one thing I do is for the authorized key file, you need to set up specific permissions for the authorized keys file. Otherwise, you're gonna have a lot of SSH issues there. And then one thing I'd mentioned was the group inheritance for the software users. So as you can see, this aspect here, you basically allow the files on the the this directory home/software to be owned by the software group, so that allows all users to basically inherit the files, and then they can edit files in that directory as well. So we're gonna run the playbook now. Just look for this command. Okay. So as you run the playbook, it'll basically just show you which task is it busy with, and if that task is being executed correctly. And like I said, because I'm running this across, I decided to use all for the host. So this basically means that all the users are going to be deployed across all nodes that are being defined in the inventory file. So the script is basically done. So we're gonna test this to see if everything went well. So we can first check the users on the this head node. You could do GC and then press it, and you can see you've created all of these users right here, including software, of course. And then we can actually switch into one of the users and then enter the password. Right. And then you could do ID, and then you can hide the name of the user. So this basically kind of shows you the groups of the user and the user ID and all information. You can see that the user is part of this group, which is basically the username, and then the software group and the pseudo group. And then because we have basically copied the SSH keys, so this user can now also SSH into the other node that exists. And you can also go to the second node as well. And then one thing you can show is, so because this user is part of the software group, you can have this user basically writing files to this software directory without any issues. You can also switch to a different user. You can also have this user writing under that directory as well. And then we can exit and go back to our original Ubuntu user. So we'll first just confirm that all files are there. So you can see the 2 files we just created are basically there. And then we're going to try to create a file under the same directory as well. Just call it test3. And then as you can see, you're not allowed to create a file there. And for obvious reasons, it's because the Ubuntu user is not like under the the software group. So that's why you can't create that. You can see all the groups here. So it's not under the software group. So yeah, that's it, guys. This is how I went about creating users for our cluster. And obviously you can tweak the script to basically fit the kind of design you want. And yeah, so that's it.